This is Mackenzie Anderson. This is my second video for chemistry. The first question, I wrote down how I got the answer right there. I just took everything from the question and plugged it into this. The second question, the papers are all messed up. The London dispersion forces can be found in either nonpolar or polar molecules. They're temporary, that's what makes them weaker. B, hydrogen atoms are so small they're able to get closer, which makes them form a stronger attraction, kind of like holding a positive and negative end of a magnet together. C, boiling point is the temperature at which vapor pressure above the surface of liquid becomes equal to external pressure. A small amount of vapor will form if the intermolecular forces are strong. That means that the vapor pressure is lower. So then to make your vapor pressure equal to the external pressure, you have to increase the temperature, which would make your boiling point higher. For number 3A is the molarity of a solution containing 0.85 moles of NaCl in 1.6 liters of solution. So here is my formula. This is what's given in the question. So it's just plugging those in to that. And that is my answer right there. B, how many grams of dextrose must be added to prepare 250 mils of 4% dextrose solution? So here is my equation. That is what we are trying to find. These are what we already have. So that is the formula, plugged what we have in, and that is my answer right there. For 4A, adding salt increases the boiling point of the solution. For B, here it's like a two-part on my pages. So here are the equations. This is just what all of these mean so I can remember. So here it is. So just taking everything we have from the question, plugging it all in, getting that, plug in for the second part, do the math. That is what I got right there. For 5A, so writing the equilibrium constant expression, this is it right here. And then explaining it. The equilibrium constant shows the product and reactant ratios. So in the formula, H2O in it has a coefficient of 2, and that is our product. And then the reactants are H2O, that has a coefficient of 2, and O2 has a coefficient of 1. So H2O, coefficient of 2, H2 coefficient of 2, and then H2O coefficient of 1. For B, I do not know how to say his name. So for this principle, changes involving pressure, volume, temperature, concentration, they will cause opposing changes in the system to reach equilibrium. If your concentration is reduced, the equilibrium will shift the opposite way. So it'll move forward, which will move towards the product, which would be the H2O in this case. And then for C, where are we? The temperature, if it increases, the equilibrium will shift like in the opposite way. So it will shift backwards towards the reactants, which are the H2 and O2. And then D, adding a catalyst to this will not affect the equilibrium. Like how it shifts, the catalyst will only affect how long it takes to reach the equilibrium, not like its actual position.